Hi, hello everybody. Welcome back to BMS Academy of NEET Physics. This is Mr. Bhanumurthy Srushti, BMS, Senior Most Physics Faculty Member, Physics Tuition Master in Hyderabad, having 30 years of teaching experience, conducting online, offline tuition classes for NEET aspirants and IIT JEE mains aspirants. This is my own house. We are conducting classes from here only. It is situated in Hariharapuram Colony, BN Reddy Nagar, Vanasthalipuram, Hyderabad. Thanks for joining with me. Yeah, in this video class, for more details, you contact my phone numbers directly. You can talk to me directly. My numbers are 9885277893 or 9652901063. If you like this video, please do like, share and subscribe. Do viral this video to all your friends circle so that everybody can get the awareness. Now let us move to this video class quickly. In this video class, we are going to discuss motion in a plane chapter we are selecting, and the topic is a projectile. Very important topic now. Every year in mains entrance examination as well as in NEET entrance examination, they are asking one question 100%. Okay, it is coming frequently on this topic. So I want to give some important concepts regarding projectile. Okay, listen carefully. Now this is called as a projectile. A body is thrown into air by making some angle theta with horizontal with some velocity. Then it follows parabolic path because it experiences gravitational force at each and every point. So its path will be deviated towards the ground, as finally it follows parabolic path and finally reaches the ground. Okay, now initially the velocity vector is given as u equal to, it resolves into two components because it is two-dimensional motion. So u bar is equals to u cos theta I bar plus u sin theta j bar. So we have to resolve this vector first of all. Initial velocity vector it is. Okay, and velocity after t seconds, because as long as time goes on, its vertical velocity decreases, but horizontal velocity does not decrease, because horizontal direction there is no acceleration at all. The body will not be experienced by gravitational force along x-axis direction. So along x-axis direction there is no acceleration, so velocity is constant everywhere throughout the journey. But vertical velocity changes from point to point. During upward motion, velocity decreases. During downward direction, velocity increases due to gravity. Okay, so in the upward direction, it possesses negative acceleration due to gravity. In the downward direction, it possesses positive acceleration due to gravity. But remember that acceleration due to gravity is having only one dimension, that is vertically downwards towards the ground. Everywhere, at every point, acceleration due to gravity is one dimensional and velocity is in two dimensional at every point. It resolves into two components. Now initial velocity vector is given here, and find velocity after t seconds. Say for example, after t seconds, if the body reaches the point A, then its velocity is v along the tangent direction. Again resolves into two components there. Then u cos theta and u sin theta minus gt according to first equation of motion. Okay, so velocity after t seconds equals to u cos theta into I bar plus u sin theta minus gt into j bar. This is the velocity here. Okay, vertical velocity. After t seconds, velocity formula in vector notation we can write. But in magnitude, v equals to under root of, if you want to magnitude in the examination, so in excluding I bar and j bar, so then u cos theta whole square plus u sin theta minus gt whole square. So if you do the calculation, time will be given after 1 second, after 0.5 seconds they will give. Okay, then velocity, initial velocity is given, angle of projection is given, so everything is given there. No, you can, if you want vector notation, you can select this formula, or if you want magnitude, you can select this formula. That's all. Okay, so first concept is finished now. Let us move to next concept. My dear students, this topic is very important. I am going to project 5 concepts in this topic. Okay, so definitely they are asking one question regularly from these 5 topics, 5 concepts. Okay. Now, at the highest point, let us discuss. Now, our focus is the highest point. Okay, at the highest point, velocity is u cos theta, but of course, vertical velocity remains. This is 0. Vertical velocity, because the body cannot go outside further. No, in the vertical direction. So, vertical direction at the highest point, velocity is 0. So, what is the velocity of a projectile at the highest point? Means you should mention u cos theta along x-axis direction. Okay, now. Our point is Initially, at point O, point of projection, velocity is u. Okay, velocity is u. Momentum p equals to mass into velocity. Mass is given in the problem, and the initial momentum here at the initial point. And kinetic energy is equals to half mv square, because u is the velocity, initial velocity. And potential energy is 0 here. Potential energy is represented by u, that is 0, because it is on the ground level. So there is no height according to mg hat. H is 0, so there is no potential energy. So these are the factors now at the point of projection. Now let us focus on what is that highest point. At the highest point, velocity is u cos theta. Okay, so velocity at the highest point equals to u cos theta. What is a momentum? Momentum means what? P bar. Okay, P dash. Okay, P dash. Momentum, P fram. So at this point, momentum, highest point momentum, m into u cos theta, because velocity is u cos theta there. Okay. Now angle is given, angular projection. And what is the kinetic energy here? Half m into velocity square. Velocity square means u cos theta whole square. So u square cos square theta. This is equals to k cos square theta. Very important concept is kinetic energy at the highest point is k cos square theta. Where everybody should know this point. Okay, kinetic potential energy at this highest point. Potential energy at the highest point we want, because total energy at every point total energy is constant, half mu square, because initially its velocity is u. So total energy is sum of these two, sum of potential and kinetic, that is half mu square. So this total energy remains constant at all points in the journey. So here also total energy is half mu square, here also total energy is half mu square. But now we want potential energy at that point. Potential energy is nothing but total energy minus kinetic energy. So total energy minus kinetic energy. Okay, total energy is half mu square minus this kinetic energy is what? K cos square theta. That is what is that? Half m u square cos square theta. So then half mu square common. Then what happens? 1 minus cos square theta. According to trigonometry, half mu square into this is sin square theta. So my dear students, so potential energy at the highest point, if they ask, then u dash is equals to k into sin square theta. So all these formulas I am putting in the boxes. See here, this is kinetic energy, this is momentum. Whatever the factor they may ask here, they can ask in examination. So it may be potential energy, or it may be kinetic energy, or it may be total energy, whatever it may be. Okay, at the highest point. Our focus is on highest point now today in this video class. Okay, so now what is angular momentum of the particle? Angular momentum of the particle, because particle is rotating in two-dimensional system, no? So it possesses some angular momentum. Angular momentum is linear momentum into perpendicular distance from the point of projection. So they may ask here angular momentum, very important topic it is, angular momentum of the particle about point of projection at the highest point. Our focus is on highest point only. At the highest point, about point of projection. Point of projection is O. Okay, about this point of projection, at this point, angular momentum of the particle with respect to point of projection we want. Okay, so what to know? Angular momentum is equals to linear momentum, that is at the highest point, linear momentum is mu cos theta. Okay, linear momentum is p dash here, mu cos theta, into perpendicular distance. This is the definition. Okay, so perpendicular distance from what? From with respect to point of projection. So with respect to point of projection, perpendicular distance up to this mu cos theta. So L equals to mu cos theta. It's a vector, momentum vector, linear momentum vector, into perpendicular distance means what? See, for this vector u cos theta, mu cos theta vector, this is a perpendicular distance. Okay, perpendicular distance is this is called as perpendicular distance. It is represented by h maximum. So this is one of the important parameters of a projectile, that is h equals u square sin square theta by 2g. Every student you know that. Okay, u square sine square theta by 2g. This is one of the parameters of a projectile. Okay, so I am writing here h means what? U square sine square theta by 2g. Finally, what we are getting now here, let us discuss. L equals to, what happens now? So then what happens now? M u cube sine square theta cos theta divided by 2g. This is the formula, my dear students, for angular momentum. I think in the last year or 22, 23 or 24, they asked in mains entrance examination. They also asked in NEET entrance examination. So my dear students, this is my way of explanation in these tuition classes now. So whenever you want, if you are impressed with this video class, then you please contact my numbers directly, 9885277893, 9652901063. So you please contact my numbers directly anytime. I'm available now, round the clock I am available now. Long-term students can fix the schedule from 9 a.m. to 4 p.m. daytime classes. Okay, so any 1 hour I'm going to take the classes for long-term students. For intermediate regular students, MPC and BPC students, you can arrange your time in the early morning hours as well as in the evening hours after 6 p.m. After 6 p.m. To up to 9:30, 10, 11 also I'm available here. Okay, so I'm taking the classes. A very good response is coming from the parents and students point of view. Okay, now let us move to another concept, very important, torque concept now. So in this concept, what is the, let us discuss this concept also. What is a torque on the particle? What is a torque applied on the particle when it is at the highest point in the case of a projectile? So at the highest point, a torque on the projectile we want to discuss now here. Torque is nothing but with respect about this point, about the point of projection only. Okay, so torque equals to force into what force? Gravitational force into perpendicular distance. This is the definition of torque. It is a turning effect of course. Particle is turned towards the ground. No, it is rotating, turning about the fixed point, about this point of projection. So it is turning effect. So it is a product of gravitational force, because for the projectile the force is only one force, one dimensional gravitational force, because g direction is unidimensional. So that is vertically downwards. So gravitational force also vertically downwards. Okay. So now gravitational force, let us discuss. So at the highest point, gravitational force is nothing but mg here. Let us discuss. Let us extend downward direction. That is F equals to mg. This is gravitational force on the particle. Okay. So mg I am putting into perpendicular distance from point of projection. From point of projection, perpendicular distance is nothing but, what is this perpendicular distance? R by 2. From O to this point, final point, range it is called as. It is also one of the parameters of a projectile. Range means from point of projection to this final point, range. So half of this range it is exactly. Okay. For this gravitational force, this distance is perpendicular distance about the point of projection. So I am putting here perpendicular distance means R by 2. So I can write mg R by 2, where R is the range of the projectile. What is R here? Range. R is nothing but range of the projectile. That equals to u square sine 2 theta by g. Otherwise u square 2 sine theta cos theta by g. So we can substitute this range value in this equation. You will get one more formula, torque formula. So tau is equals to mg by 2 into u square 2 sine theta cos theta divided by what is that? That's all. By g. So g gets cancelled here. 2 gets cancelled. Finally, we are getting what? Tau is equals to m u square sine theta cos theta. This is the torque formula in the case at the highest point of the projectile. So my dear students, this is my way of approachment, my teaching methodology here. We are going to conduct all, what is that? We are going to conduct all concepts from conceptual models. We are going to project to the students in the tuition classes from each and every chapter. Okay, so listen carefully now. So if you are impressed with this video class, okay, just only formulas and conceptual models I have given to you. Whenever you join, if you are impressed with this video class, whenever you join in this video tuition classes academy, so everything will be projected to you regarding NEET entrance as well as IIT mains entrance examination. So many students got good ranks from this academy. Remember this point, okay? Thanks for watching my video classes. You keep on watching my video classes because nearly 60 video classes I released from 2 years ago, from 2023 onwards. I'm releasing nearly 50 video classes. Okay, you keep on watching all those my video classes, and if you like this video, please do like, share and subscribe, and do viral this video to all your friend circles so that everybody can get the awareness. Okay, so my dear students, my timings, everything well. For more and more details, go to the description box given below, and my website is bmsphysics.in. Okay, so academy is there, but from this academic year I'm conducting classes from my own house, situated in Hariharapuram colony, Vanasthalipuram, Hyderabad. Okay, so long distance students can hear my class online classes. All the students are hearing my video classes, online classes. So they are getting a good benefit now when they are beneficiaries for me. Okay, actually, some more details. Okay, wishing you all the best. Okay, have a good luck. Let us meet in the next video class soon. I think most probably tomorrow only with a new topic from new chapter. Till then, bye, goodbye.